Hello, hello. Today I have Mind the Gap by Michael Lefkowitz. And he's told me that this is, to him, one of his best puzzles in a while, which for him is saying something. So I'm very excited to try this. He also warned that it was quite difficult, so we'll see. Normal Sudoku rules apply. That means I have the digits 1 to 9 once each in every row, every column, and every marked 3 by 3 box. Safety strips. So these safety strips are essentially black crop, excuse me, black crop key dots, digits along or adjacent that are separated by a yellow safety strip are in a 2-to-1 ratio. So for example, I could have a 2 here and a 4 here. That would be good. Or a 1 here and a 2 here, or a 3 and a 6, something like that. Gap loop. Extend the gap, black line. Okay, that's this line. Along cell edges so that it forms a single loop which cannot touch itself. Even and odd digits may not touch except across the gap. Okay, so I'm going to be extending this. Whoops. Oh, I have center only on. Edge only. Extend this in such a way that we end up making a loop, maybe something like this. And even and odd digits will only be able to touch each other. How could this work? Something like this. Okay. Oops. Something like that. Even in odd digits, I mean, this obviously is not going to be correct. Even in odd digits may not touch except across the gap. Pathfinder. Draw a path from the blue dot, okay, we'll do this in blue, to the red, well, I guess I need center and edge. Blue to the red pin, which moves orthogonally and diagonally. Okay, because this actually can move diagonally too, so we could do something like this. It can't cross the gap or touch it at the corner of itself. So we can't do something like this because that would touch the corner of the gap. And it can't cross the gap, so I couldn't do that either, except at yellow safety strips. Okay, so I drew one here. So I didn't draw one where I go in and out, but maybe if I drew the gap like this. Oh, that was a real gap. Well, whatever. I think you get the idea. I can go through, these essentially act as doors across the gap. And if there were another one here, I could get out through here and move back around, something like that. Adjacent digits on the path differ by at least 3. Okay, so this is a 3 whisper line. I don't know if that has a particular name. I haven't seen a 3 whisper before. Those are the rules. Okay, so I think it's first worth, and I knew to think about this because Michael actually asked me to help with this puzzle under a different rule set. I wasn't able to, but because I think we decided that it was impossible for that particular rule set to work. But anyway, I think it's worth talking first about this loop and what it's going to imply. I think it's going to imply a cave-like structure for odds and evens, by which I mean I don't know if it's going to be evens or odds, but one set, let's call it odds, will be kind of inside this loop and be orthogonally connected, and the evens then will all be outside the loop, and they will form pockets that all have to touch the boundary, right? So however I draw, like if I have a loop, it doesn't matter, and it's not because of the way these specific givens are drawn. If I have any loop, right, and I say odds and evens are only allowed to touch across the gap, what that means is, these will be one type, right, and anything it touches that's not across the gap will be that same type, and then when I cross, I'll get to a different type, and then everything outside that is going to be a different type. So this loop is essentially going to define the boundaries between odds and evens. Like, remember, whichever one is the outer could have multiple pockets that all touch the edge. So let's start here. I'm going to use blue and yellow, so I don't know what's odd and what's even, but it's not directly in the rules, that across a gap they have to differ. The parity of the digits have to differ, but the implication of the rule is that, I mean, if they didn't differ, we'd only have all odds or all evens in the puzzle. So they are going to end up having to differ across gaps. Because there's only one loop. If there were multiple loops, that wouldn't be true. But if there's only one loop, then there is one. So I don't know how to describe this in more rigorous terms. So basically, if there's one loop, that loop is going to have like a convex. I guess it doesn't have to be convex, but there's going to be an inner boundary to that loop that will be a contiguous shape. That contiguous shape will all be the same type. And then outside of it, there will be no boundaries to change either. So anything on the outside is going to be the same. Oh, I can actually, actually, I think that's not quite true. Hold on. Because there are multiple pockets, I suppose it's possible. Yeah, I didn't think about this. I suppose it's possible that things wouldn't differ across a particular border. So for example, I mean, it's not going to work exactly in this setting, but like you could imagine a world in which, you know, the yellows were inside and the blues were outside, but this particular pocket was also yellows, but there were other blues elsewhere that made that work. Actually, that could work, which is kind of frustrating. Annoying is not the right word. It's frustrating my ability to solve the puzzle. Okay. So they don't necessarily differ across a boundary. Huh. What else can we do? Well, let's start extending this loop. So I know this loop is going to go up. It's going to go down. This loop could go up or down. These can go anyway. This, no. Yeah, this could do anything. Hold on. Okay, I think this one they do have to differ. Because if they don't, then these ones won't differ either. Well, hold on, can I do, I'm trying to decide if I can make this do something like this. I guess that doesn't help. Or so the thing I'm worried about getting too many, not worried, I'm hoping that I can say that these are different parities so that this is, well, I'm hoping to just get, let's start here. I hope these are going to be different parities. I suppose they aren't. Like, let's suppose those are all blue. And there's no loop here, so that's going to be blue as well. And there's no loop there, so that's going to be blue as well. There's no loop here, that's going to be blue, no loop here. So these would all be the same parity. If we have a section that's the same, an outer loop section that's the same as the inner loop section, these all end up being the same. And these they can't be even, because then these would all be odd, and I have 6 odds in a row here, so this would have to be odd. But these would also have to be the same parity, because, oh no, these could differ. I could have an odd and an even. Okay, well these would definitely be different, because if they weren't, I would end up with, because blue is now odd and yellow is even in this hypothetical world. And if either of these were also odd, that would force 3 evens in a column here. And there's at least 2 evens in each of these columns. I mean, another way to think about it is this. There's at least 2 evens in each of these columns. Because there's at most 1 odd. So there's 4 evens here. These are even. And there's exactly 2 evens. So the extra odd in these boxes are in this column. These would be even. Which means I need to draw a gap here. Which means I could do this. This seems... How do I show that's not possible? Well, this can't be blue because that would force this. But if it's blue, this has to be yellow by the number of evens and odds in the box, and I wouldn't have a gap there. So that doesn't work. This is yellow. This is a lot of work to disprove one thing. I thought this would just like immediately fall. But it's trickier than I thought. One of these has to be a boundary. I don't know which one. But it could do something like this. Right? Oh, I have to be a little careful up here that I don't touch these 2 loops can't touch together. Can I do something with counting? I really want to I want to avoid situations like this. Because I think it's going to be very hard to disprove that possibility. I suppose, well, there's only 1 more yellow here possibly. How is that going to work? There's only 1 more yellow in here. And it's got to be on this, so these would all have to be blue. Which means I would need to get, yeah, this just isn't going to work. But it's very complicated to see. So these are going to be different types, so the gap has to go this way. And this will go in the direction, and I need a gap here. This can't connect to itself. Yeah, this breaks, but that's really hard to see. Did I just choose the wrong? I mean, this is the biggest one. Where else would I start? Where else could I put? Was it this one? Well, it is. I mean, these certainly can't all be the same because there's 6 of them. And I can't draw gap lines. So I know that these 3 are the same parity because I can't draw gap lines between them. And I know that these 3 are the same because I also can't draw gap lines between them. And therefore they have to be different than those. Okay, so let's start there. That's at least something. And then here I need at least 1 even. I see. So there's 3 evens accounted for. I don't know whether it's these 3 or these 3. But I have 3 evens accounted for. This is going to have an odd, and this has to have at least 1 even, so the other two will be odd. So this is odd. I don't know whether odd is blue or yellow, though. But I do know that's 1 of each, so I need to have the gap boundary around it. And now if I go down, I can make this blue and these yellow. If I go up, this will be yellow, this will be blue. This could, hold on, if I go up, blue, yellow, but that could do either way that way. So I don't know how that goes. What about here? Is there any way these are both yellow? They definitely can't, no, they could both be blue. It'd be hard, but I think you could do it if you just loop this around a bunch. And on this one, either these are all the same, or, well, no, these are all the same. The question is this also the same as that? These can't, I can't draw boundaries here or here. So these are all the same. I just don't know which they are. If it's yellow, no, I don't know what it is. These are all the same. These are all the same. These six are all these six are all the same. These six are all the same. That's the way I should be thinking about it. So let's call that orange for a second and see if that helps me. Well, orange can't be even because I need another even up here. So the orange is odd. Okay, these are all odd. So I have one more odd to play with in this column. Is there any way those are also odd? And let's call those, let's call those purple for now. I don't know what these are because there's no safety strip. These are all the same. Okay, and these are all the same and they're not orange. Again, because I can't draw a gap in either of these places. So these are all the same. Let's call that, I don't know. All right, let's get rid of these for a second. I'm running out of colors. Let's call this blue. And blue and orange are different. So the gap either goes over here or it goes over here, or both, I suppose. And no, these could both be even. I was gonna say one of these are odd. That's not necessarily true. Orange is odd. This could go up. There's nothing stopping that. I wonder if I'm going to end up. Did I draw this, or is that? I drew that. Okay. Oh, but that is real. Even though I don't know what colors anything is. Oh no, these are different. So purple is orange because again I have 6 here. And now, and orange is odd. Orange is odd, so it's 1 or 3, and this has to be even. Okay, so these are blue. I have 3 blues that are even. So there's 1 more even in this row. It's probably not here, right? Could this be blue? I don't know that it really matters, but let's can you think this one is not anything, this one's not anything. Those don't have to be the same, those could be different. If this is blue, these are all orange, which doesn't work. Okay, this can't be blue because blue is even. So if this is blue, these would all be orange. I would need a gap here and here, which doesn't work. So this is in fact orange. I could probably do similar things. At least one of these is orange, possibly both. So I'm gonna have, the gap is gonna have to go on one of these spots at least. See, where is the other blue? If it's here, these are all orange and I get gaps over. It can't be here, no. This can't be blue, because if this is blue, the rest are orange, I would need gaps here and there, which doesn't work. So that is orange. This could be blue quite easily, I think. I don't think this can be orange. Ooh, no, it could. It could. Wait, no, it's blue. I'm trying to think which can't be blue. Could this be blue? No, because if this is blue, I would have lots on this corner, which doesn't work. So this is orange. I don't think I can do more than that. Could this be blue? I would need gaps everywhere. This would need to loop around, and so this would have to go over. And that would make 6 oranges, which doesn't work. So that's orange. There's no 2x2 restriction, right? I don't think there is. Yeah, there are no 2x2 restrictions. If this is orange, these are blue. Don't see the problem there. There's one more orange here. Can it be here? No, so this can't be orange, because if this is orange, then we need the gap to go in like this. And the only way for the gaps to work is, oh no, that does work. Oh no, yeah, it breaks here. And then we end up with a little second loop, so that doesn't work. This has to be blue as well, which means there's 2 evens here, so there's definitely a 4. And the other one's either 2 or 8 on this essentially black Kropke dot. I guess I can say this is 2 or 6. One more even. There's no way it's this one, right? If this is blue and this is orange, we need gaps. Oh yes, that doesn't work. This is orange and this is blue. So the line is going to go up. I guess we could go this way. Now the problem is I can go down. I don't have to. I'm not restricted by. Say that has to be there. I'm not. If along a color, I don't have to go across it. I could go through. So yeah, it's quite complicated how to think through this. Does this one have something now? The oranges? No, this could still be orange. Six is one of these for sure. Put that in. If this is orange, it's 1, 3, but a different 1, 3 from this one, because these would be different for 6s, 2 6s. It probably is orange. Well, if this is blue, we have to do that. But I don't see any issue, actually. Okay. If this is orange, that's all my oranges, so these would become blue. Yeah, it doesn't help me here. These can't both be orange now because I've got 4 oranges already, so those are in fact blue. Now these are 1 each. Yeah, I don't know. These are the same, these are the same. Is there any way this is all the same? If they were all the same, it's hard to see. Okay. Two evens in these. This is 1 each. Got 1 odd between these. Can this be odd? I think not. Yeah, if this is odd, this is even, and we have to draw a boundary through here. So this, I mean, this can't be blue. Well, no, this could be blue. This can't be, what I said, this can't be orange. Because if it were orange, that's 5 oranges in the row, that would be blue, and I'd draw a gap through this corner. So that's blue. It doesn't necessarily mean this is orange. I don't think. I really want to say it does. What happens if this is blue? If that's blue, this gap has to go up, and we end up in this situation. No, but this can go down, I suppose. Like you could do something like this. Well, hold on. No. I can't go down here though, so I end up with 5 blues. Yeah, if this is blue, I get 5 blues in both the row and the box. That doesn't work. This is the kind of stuff I'm not very good at, so it's hard for me to see. I have to draw it a little bit to see it in a way that, I don't know. Apologies if you think that's bifurcating. So this is in fact orange. This is in fact blue. That's my blues in here. That's orange, and now we draw our boundary like this. This has to go, ooh, does it have to go down? I don't think it does. I could go up. Yeah, I don't know which way, because these could just easily connect around here, or they cannot connect and we are in some different land. Okay, there's one more orange here, which completes the orange in this box, so that's blue. Or I can just see there's 5 oranges in here. The gap has to do this. Now this is going to connect to, yeah. So now this, this line here has to connect to one of these two. But if it connects to the top one, this one's gonna have no way to get out. So it has to connect to the bottom one somehow. So this one can't go to the right, it'll be stuck. This one has to go left. And if it goes left, it can't go down, it'll hit there. This one does have to connect like that. I can't really see it, but maybe I should have done all those in like pink or something. But this does go up and around. I still have this dangling and this dangling, which don't have to touch, but they probably will. And this is my 5 oranges, so these are blue, which means I have gap here and I have gap here. If this is blue, we have to extend it here. If it's orange, we have to extend it like that. So either way, this ends up connecting to this. I just don't know whether this, and same thing here, right? This can't go up, so it's got to come over here. And so if this is blue, it's going to connect there. Or if it's orange, it's going to connect like that. These now, so these all have to be different. I have 3 oranges, so these are blue. These are orange. I've got, no, oranges are odd. So I have 1 orange and 2 blues left in here. I have same thing, no, here I have 1 blue, 2 oranges. I really wanted to say those have to be different, and that forces us to be orange, which will do some work here. Is there any way those are both, like, can I possibly do this? How would that work? I don't see an immediate reason it doesn't work. Like I could do this or something. Like very, well, I couldn't do that actually because then blue and orange would touch. So how would I force these two to be different? How do I get a border there? It'd have to be, hold on. Maybe it's actually this one. What happens if this is orange? If this is orange, I need a wall either here or here. If this is blue, we've got to go up and over. And then I can't have another cage here, so this will also have to be blue. And I can't do another cage here, so this would have to be blue. But if this is orange, well, that just can't be orange because, well, hold on. Can this just not be orange? If this is orange, no, we just draw this wall down, that's fine. Wait, so what was the problem? If this is orange, and this is orange, we get a wall here. If this is orange, and this is orange, we get orange in all of those. If it's blue here, walls here. I just can't, I'm bad at visualizing this kind of thing. The only way that a wall cuts through the same color is if that entire color then gets to the edge. Which I guess if this were orange would just be up here. It's just very hard for me to think about. Like there's probably some type of like odd even checkerboard logic that does something, but it's complicated. I can't figure it out. So I'm stuck trying to do this on individuals. Okay, I'm pretty sure these can't both be orange, but it's a lot of look ahead. If these are both orange, these can't both be blue because I would need gaps on this wall in 2 places across this corner. So at least one of these is orange. If this one's orange, we end up with wall here. Which means this also has to be orange. So what we've learned so far is, so if this is orange, at least one of these has to be orange. Sorry, these are both orange, at least one of these is orange. But if this one's orange, this one's also orange. Separate from this, I mean, it's just as a separate deduction, I can say, if this is orange, then this is orange. Because that will put, if this is orange, that puts a wall here, and around corners, you have to have the same color. So if these are both orange, then at least this one's orange. We get 3 oranges like this. We'd have blue here. And then this can't be blue now because we would need walls here across this corner. So if these 2 are orange, these 2 are orange, which makes this blue and this blue, which is going to put walls, oops, this is going to make a lot of walls. This then would have to go like that. Which, no, that doesn't work. I did something wrong. If this is all orange, we get walls here and here. And these are blue, so we need walls here and here. Where does this go? It just like goes around through a bunch of orange. This have to go over. This will be orange. I have an orange and 2 blues. I don't know. I can't see it. It doesn't seem possible, but it's hard. Okay, can this be orange? Yeah, I was thinking it couldn't be, but that was in the other world where I had some oranges up here. This could be orange if this is also orange. And then we'd have the wall go like this, which is possible. I really wish I could say, because if I could make this orange, that would do so much. But I can't. Well, this is 1, 3. This is a different 2, 6. These, therefore, are 4, 8. These 2 digits are these 2 digits. Yeah, so I kind of have like roping on the blues. Does that mean I have roping on the oranges? Probably. I might actually. Hold on. This digit is one of, like, do I have roping in rows? Like, is it true that this digit is this digit for sure? And this digit. So this digit is one of these two. Hold on. I do have roping, I think. Look, because this is... hold on. Let's call this purple. And this yellow. These are purple and yellow. Well, what did I see? Like if this is purple and this is yellow, we're done. I mean, or either of those would do it. Is there any way yellow? Is there any way this is yellow? I think there is. This could be yellow, this could be purple. Purple's in here. Yeah, I don't think we quite have it. Okay, whatever. Is it this now? Okay, it's got to be this, but I wish I could prove that across boundaries you had to switch parity. Is there a reason this can't be blue? I don't think so. Okay, if these are both orange, I'm just going to draw it out. If these are both orange and that's blue, we said these both have to be orange. And I end up with this. I have 5 oranges here, so these are blue. This comes up and around. And then what? And I have 2 blues in here. It can't be those 2, so this one will end up being blue. This we know is orange. One of each, it really doesn't matter which way it goes. We end up looping up here somehow. One of these is blue, because it's on a safety strip, which has an even digit for sure, because one is double the other, so that will be orange. These will be blue. Yeah. That's a long way to look. All right, now that I know where the break is there an easier way to see that? If this is blue, okay, I see. One of these is definitely blue at least, if not both. So if these are both orange, the problem's going to be with this point. So because this is going to end up looping around, if these are both orange, these are all orange, we get boundaries here and with blues. And so this ends up having to loop around, which means these are both orange, which makes a bunch of blues here. Oops. But we also know that yeah, so I need gaps here and here. I don't know. I mean, I definitely can't see that in my head, but I don't know what else to do here. I would like to just conclude that these are one each anyway, but I don't think I've actually proven that, because you can have like this. These could be orange, except that they're, you know, limited by the rest of the puzzle, but there's nothing about the boundary that says those have to be. And so I don't think there's inherently something that says this has to be both orange either, but it doesn't work. I'm going to use it because we're pretty long on time. So that's blue. No, sorry, that's not blue. That's orange. I was going to say, what did I want for that for? And which gives us that this is orange, which gives us that these are blues. The boundary here goes left. This one eventually connects to, oh, do I know that for sure? I don't. This could go over here and this could go down like this. I don't know that for sure. All that, and I don't have much to show for it actually. Is there something about like if this connects to here, say, that's going to break the inner outer. Like my oranges are my inner and my blues are my outer. So like there's probably something about like the clockwise, anti-clockwise-ness of these lines that will tell me something about the color, and that could tell me potentially what has to be on which. The problem, of course, being that you could have an outer loop that's orange. You can't have inner loops that are blue, but you can have outer loops that are orange. You don't over here. Yeah, I guess maybe one way to think about this is if these are both orange, one of them would be like this is an inner loop orange. So I mean, one of these would be an outer loop orange that would have to get to the wall via outer loop oranges. So they would have to go this way. I think that's the way to think about it, is rather than that bifurcation I did. Like, let's go back a second. If these are both orange, one of them is an outer loop orange, which has to get to the wall using only outer loop oranges. That's the thing I think I was missing before. And so these are inner loop oranges, these are inner loop oranges, these are inner loop oranges. Actually, I don't know about these, but regardless, one of these has to be blue. Does that help me actually? Like, what's stopping an outer loop orange that does? Ooh, is that what this is for? This is mean. I can't get, if I go to the right here, because this is outer loop, this has to be inner loop, so I can't get it for you here. I can't do that either because that's gonna brush, like I need a path. Ooh, could it be that though? And that. Maybe. Well, then these would both be odd, so that doesn't work actually, right? So the safety show, like all these things are telling me this outer loop can't touch the wall. Because if I go here, I've got to do that, then I need another boundary there. If I include that, I break the safety strip. I can't go up ever because that's going to cause this blue to not be able to get to a wall. Ooh, what about this? What about that? Does that work? It might. Or even just this. Does this work? I think this. Well, no, I could do. No, I could do that. This line could go around like this. I can get an outer loop orange like that. But then I just have so many oranges that it's laughable. Because these be orange and everything on this side of the loop would also be orange. Like it's just too many oranges. Well, first of all, I have way too many oranges in this row. Yeah, maybe that's because I have 2 oranges already. If these are oranges, if I go down, I can't go down again. So I have to go third down. Now I have to go down again. Because this is outer loop, this is inner loop, this is inner loop, this is inner loop. So this can't be, this is the inner loop orange if it's orange. So this is the only outer loop orange possible in this. I have to go here, that's 3 oranges, so I can't go up or down. I have to go down. I can't touch this, I can't go across. Yeah, that's it. That's the way I should have thought about that. Okay, now let's see if I can, nope. So all that is to say these are different. The inner loop here, wherever it is blue. So that's orange, because that gives me my 4th blue here. That's orange. These are blue. Um, 8 minutes from when I did that to try to explain it in a better way, and I don't know that I did. These are probably both even, but I don't know that for sure. I've got an even here. That's my 3rd even. Oh, that's odd. Now that I know what these are, that's odd. That's orange. Is there any way this is outer loop? How would that be possible? I guess we could do something like this. And then this. I don't know. Again, I'm just not good at visualizing these things. Actually, if these are orange, it does a lot of work. It makes these blue and these blue. I don't know. Only one of these is blue. Yeah, of course. One of these is blue, one of these is blue. Can this be blue? No, if this is blue, this is orange. Yeah, I can't have a checkerboard. If I have a checkerboard of colors, I do something like this, right? Which doesn't work because the boundaries will touch. So if this is blue, this is orange, which breaks this. So this is orange, this is blue. These are all the same, so that's blue. Oh wow, it is, holy cow. So how's this gonna work? I thought that wasn't gonna be possible. This has to touch the wall. It could go straight down, I suppose. Except I need 4 in the, I need a blue here. This probably connects in like that. But maybe not. And maybe it does this. No, it can't do that. Well, can this be blue? Maybe. That might work. I don't know. Yeah, this could be orange. Yeah, I have no idea how the boundary can do. It can loop up to get a blue. Two blues, or they can be in different spots. They can be. Hold on. Can it be those two? Yeah, that's okay. Oh, no, I need two blues. Yeah, that's okay. All right, I can do that. So there's nothing about the boundary that tells me anything about that. That's going to come from Sudoku. Evens odds. Can I do something with the path? Like, is it? I would be very amused. Well, it's not going to work. I was going to say be very amused if the way this ended up solving is to show that the path just had to go like this. And yeah, but that's not it. Because I'd end up having too many blues here. But I could maybe just do this in orange. That's actually possible. I think still. This blue has to get to the wall. How is this blue getting to the wall? With one of these and one of these. I guess we could do this. That seems fairly straightforward. That's blue, fairly clearly. So I get walls here and here. Because this corner now, this is blue. I have one more blue in here. So now this can't be blue because that forces this orange. So this is orange. We get the wall going around like this. Whoops. And again, it can go up and around either way. It doesn't really matter. And this connects to here. So this can't go left because if it goes left, it's gonna, like these are all connected here. So there's nothing to connect to. So this has to go right. I don't know though if it goes up here and then this is blue and this is orange, or if we go around like this, or even like this maybe, to there. That's also possible. Well, hold on. This one's not possible because I end up with too many blues. Oh no, I don't end up with too many blues. That's okay. So yeah, I don't know which way that's gonna go. I'm wondering if this has to, now let's think about this path. Because if this is orange, there are no safety strips around here. So if this is orange, orange has to go through here. And then either up into this area, and then potentially straight into this, or down here, and then into blue and back, or something like that. Yeah, no, there are too many ways that could work. I was trying to think of a reason that orange had to go here, but I don't think it does. Hold on, if this is blue, this is blue. Yeah, no, that doesn't work. Here we go. If this is blue, and I can see this, that mark happens. And now, that makes this orange. Or sorry, that makes this blue. And now I have one of these are orange. Oh no, that doesn't break the way I thought it did. I thought I'd have to draw a line vertically down like this, but that's not true at all. Oh, but it does separate these oranges from these oranges, which is easier to see actually. So hold on. Yeah, these oranges have to get out because the oranges are all connected to each other because they're the inner loop. Because this blue is clearly on the outer loop. So this is inner loop. Inner loop has to all connect, so that is orange. And because there's a corner here, this is now orange, which makes this blue. This is probably blue. Because if it's not blue, if it's orange, blue has to connect to this wall, which is going to be tough. But I can't immediately say that's wrong. Okay, only one of these is orange. So actually, maybe this does go over like this and down like that. And then orange can connect to itself like this. Well, if this is blue, this is blue. I don't know. Well, I get wall up here. I don't think I've drawn that. So how do these walls connect? I guess it could either be like this, if that's orange, or like this, if it's blue. Which is fine either way. I have a loose end over here. Yeah, because this is inner wall. This is inner loop, I mean. So there is wall up here too, or gap, I guess, which has to get out. So this is going to be orange as well, which means this is all blue. Let me just explain that again, because that's kind of hard to see maybe. So I've got how many ends do I have in this corner of gap? 1, 2, 3, 4, 5, ignoring this one I just drew. So because there's 5, one of them is not going to connect to another one in here, and so it has to leave this area. Well, how's it going to leave this area? Actually, I have to be a little bit careful, because in theory, I suppose this could be, so these are all inner loop because they border outer loop, because blue has to be outer loop. So these are definitely inner loop. So there's no loop in between. Like this is all inner loop, there's no loop in between it. So there's no way to get out through here. So one of these, I don't know which one, I think it has to be one of these. But one of these 5 is not going to connect to the others and can't get out through here, can't get out through here, is going to have to get out through this outer wall. And since this blue is outer loop blue, this is inner loop orange. Actually, maybe this can connect here. Maybe I was wrong about that. What happens if I connect up here? This is inner loop, so we'd have to do something like this. But this might work actually. Wow. Well, hold on. The problem is now if now I need blue here. So if there's a wall up here, right? If there's a wall here on this spot, then this orange has to get to one of these spots. But I guess it could do this. Yeah, that actually works. Even with 5 orange. It doesn't work here though. Hold on, I only have one more orange to play with here. Okay, so that's part of it. I only have one orange left in the row. So if this wall and this orange has to connect down to here, then wherever I go, I have to go down twice in a row because I can't do any more. If I do that here, It doesn't work here. So I have to go down twice in a row here, over, over. But that still works as well. These are blue. This has to get to a wall, which it can't easily because there's a wall here. Man. Okay. So I was wrong about there not being able to be a wall here, but I think I'm still right about there having to be a wall here. Now do I think about the path? The path does differ by 3. If it has to go out this door, or this safety strip across the gap, that does force this to be 6, 3, which is interesting. Forcing this to be 1, 2, and then I'm kind of stuck out here. And then maybe I could do this. Something like this is possible. That would do a lot of digit work. Okay, this is 1, 3. This is 2, 6. I wonder if I have to go through this door. It feels like I do, but well, there's only, let's think about can this possibly be odd? And the answer is no, because if this is odd, we get even, odd, and evens in a little world. So this is blue. At least one of these is blue. Can these both be blue? Maybe. Actually, yeah, maybe. No. These can't both be, wow, these can't both be blue. Watch, if these are both blue, these are orange, and this is orange, and orange has to connect to itself, so we get there. And now, I said before that checkerboards is disallowed, so immediately, that doesn't work. So this is 1 each. And if this is, oh yeah, these could both be blue. This could be orange. These could be blue, those orange. Is there any way these are all blue? Blue, blue. No. Blue, blue. No, there's no way these are all blue. Right, of course they're not all blue, because one of these is blue. Hold on. Right, so most one of these is blue, so that's blue. In fact, one of these is blue, so that's orange. That's orange. And we get our wall, at least doing this. And now this can't go up, so it's gotta go, be a little careful. Now, if this is blue, this is blue. Right? Because otherwise I get a checkerboard. If this is blue, this is blue. If this is blue, that's orange. Yeah. So I either get 2 blues here or 2 blues here. And that's going to decide whether this orange comes up or comes down to here. Wow. So I guess I'll never have to go through this door, because I could go through this door instead. I do have a 1, 3 pair in oranges, which is kind of interesting. Then the next thing I need to do Um, hmm. Yeah, I'm having some trouble. If these are both blue, and the rest are all orange. And these are orange, and that's orange. Oh, that breaks. Is that too much to look ahead? I don't think so. I think that's okay. So if these are blue, watch. If these are blue, I have 4 blues here. These are all orange. These have to be orange here by oranges have to be all connected logic. That's also orange, and I get 6 oranges in a row. So the blues, the 2 blues are in fact here. These are orange. I get gaps here, like this. Orange does not have to go up, in fact. I have 1 blue here, 2 blues here, 1 blue here. And those have to be distributed somehow. 2 in this section, and 2 in this section. Oh, 3 blues here. 1 of these are blue. So these are all orange. How long? I must have had that forever. So that's blue. Can't have a checkerboard, so that's blue. This goes over like this, therefore down. If this is blue, I'm going to get a checkerboard, so that's blue. That's orange. Sorry, I don't know how long I've had that. That's probably made everything much simpler. I get this is orange, this is blue, and this is blue. Wow. All right. I still don't know this though. This has to reach a wall, so this is blue. This is orange. This is blue. This is orange. Wow. Well, I hope we're at least halfway done with this puzzle. I imagine the rest will be easier than this. But we have our gap. We have our safety strip. So, I mean, at least the path seems somewhat straightforward. If I go down here, I'm going to get stuck, so I've got to go this way. Now, I can move diagonally. And I have to somehow get into here. So either I'll go in here and then up to here, or I'll go in here. Or, oh, I bet what will happen is I'm going to go all the way up here and in. I bet that's what's going to happen. Just knowing Michael. So, how am I going to figure this out? Well, wherever I go in is definitely 3, 6. Is there something like that? How do I make difference of 3s on odd digits? I mean, it doesn't seem that restricted. 1, 7, 3, 9, 5. 1, 7, 3, 9, 1. I mean, oh, maybe it's uneven. Maybe I can't go this way. Hold on. How would I possibly do this? Because on the even digits, 2 can go to 6 or 8. 4 can only go to 8. So could I do like 4, 8? No, I guess that is possible. Oh, but I would need to do another 2. Yeah, that's the problem. Yeah, the problem is, whoops. All of these cells, it's not that there's 4 in one area, that's okay. The problem is all 4 of these cells have 2 partners that are different. And 6 and 4 can only have 1 partner. So this path is not possible. So we have to go this way. I don't know how we're going to get to here, but eventually we'll get to here. And then I don't know how we'll connect here. There's lots of different permutations of that. But I do get this. So I wonder if that, and so which means this is 3, 6. There we go. That's 1 because that's 2. That's 6. This is a 4, 8 pair. This is 2 or 6. 6 has to go to 2, which can go to 8, which can go to 2 or 4. But that's going to be 6 because it's not 8, so that's 2. 3 has to go to 7 or 9. 1 has to go to 5, 7 or 9. The 7 and 9 can go next to each other, so that's 5, that's 9. That's 7 or 9. This cannot be 5. Oh, okay, it's 3, 7 or 9. That's a 7, 9 pair, that's 3. This could be 9, 5, 1 or 9. Oh, do we have roping? Hold on, what's this? These are 1, 7. No, we don't have roping. 3, 9, 1 is not what this is. That's a 5. That's a 1. This is a 7. 3, 5, 9 in those spots. This can't be 3 because that'll be a 1. Hold on, can this be a 3? What would this go to? If this is a 3, it'd have to go to here as a 7 or 9, which would then, oh, it could go to 1. I could do this. Yeah, that could work. I can't roll that out. This can't be 1 or 3. So this can't be 7 only. It can't be 3 from Sudoku. That's a 4. Let's do easy stuff. These are 4 and 6, which makes this 2, 8. 4, 6, 8. 2 makes this 6, 3. That can't be 5 anymore. It's not 9 anymore. This can't be 5 because that's 3. This can't be 5 or 9. That's 1. One of these is a 3. One of these is a 3. Now there's absolutely no reason why this can't go across. The question is going to be like, why can't I do this? And I wonder if I made a mistake. Ooh. I'm tempted to check my digits. Hold on. I was going to say that would be a 5, but those don't have to connect. I don't know. That's 1. That's 2. That's 5. Yeah, I broke it somewhere. Oh, shoot. Okay, let's just go back to the digits. I'm not sure what I did, but I broke it somewhere. Let's go back and we'll try to retrace our steps and see where I made a mistake. So let's assume the path is right. That would have to be 3 to go through there. It can't be 1, 2. That 6 places a 2 actually first, and then which is 2 from 1. There has to be a 6. Does there have to be a 6 in one of those spots? Yeah, because I can't have 3, 6 on the safety strip. That's a 4, 8 pair, which makes this 2 or 6. To be 3 away from 6 can't be 4 or 8, so it's got to be 2. That has to be 6 or 8, but it can't be 6 by Sudoku. That's 2 or 4. That has to be 6 because it can't be 8. Because it's 6, that brings that back to a 2. Why does it have to be 5? It couldn't be 7, 9, 3, or 1, so that's a 5, which makes that a 9. Yes. That's going to end up being a 3 in the middle. 1. Oh, why can't that be 7? Is that the mistake? Oh, no, 1 if I Sudoku. Because those are either 1 or 7. Oh, no, 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 no. Yeah, that's my mistake. I could put a 1 down here. That's the mistake. This is 1 or 7. And first, in my head, I must have done that's 1, 7 pair. Resolved by that, but that's not correct. 1 isn't 7. That's 4. That's 2. That's 8. That's 2. That's 8. That's 1. And now this is not 1. 6, 4, 8. These have a 3 in it. 0, 3, and 7 or 9 is the other one. I get a, oh, by Sudoku, that's a 3. Which means these are a 7, 9 pair. Which means this is 1 or 5, that's a 1, that's a 5. That's a 1, that's a, yeah, there we go. That's a 5. This has to be 1 or 5. So do I have roping now? I think I do. Yeah, I have roping. So, or just, this is a 1. This is 3, 7, 9. This is also 3, 7, 9, I guess, by Sudoku. 8. 2 here. 6. Still unknown, right? Because it could be here, 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 or it could be here, here, here. This is not 3, so one of these is a 3. The other one has to be 7 or 9 to be adjacent from a 3. So this is a 5. So this is a 9. That's a 3. That's a 7. Wow. This could be 9, 5, 1. It could definitely also be 9, 1 or 7, 1. And then 5, 7, or 9 here. 2, 2. 2 by Sudoku. These are 4 and 6. 4, 8. 4, 8, 2. 4, 8, 6. There we go. 4, 8, 4, 8. Not quite finishing off our 4, 8s, I think. Maybe now. Yeah. Okay, blues are done. Okay, we've got to just, I mean, I bet these will resolve by Sudoku and that will finish the path. So let's try Sudoku. That's not 9. These are 1, 5, 7. One of these is a 5, so that's a 1. 5, 7. This can't be 7 now. If this is a 5, there's going to be tons of ambiguity on this path. It'd be 9, 5, 9. And I wouldn't know which way to go. So I know that's not a 5, but how do I prove that? Really? 3 is in here by Sudoku. 3 is in here by Sudoku. Oops. So now that's not a 3, that's a 3. That's a 7. There we go. Now to get through here, I've got to do this. That's a 3 by the path in Sudoku. That's a 7, 1, 9, 3. What are these? These are 1 and 9. This is 7, 5. They're both Sudoku in the path. 9, 5. 1. This can't be 3 now. That is 7. This can't. This can go straight here. How do I know it has to? Oh, because I have 7, 9. Yeah, that's a 5. Oh wow. Right. So this could be 5, huh? But that just means the path can't do either. I missed that possibility. 3, 7, 9, 7. I think that's it. Yeah. Whew. Yeah. The first half. I mean, half. The coloring half was quite a bear, but I mean, really worth it. So thank you for suggesting this, Michael, and thanks for watching. And I'll see you next time. Bye.